Objective 3, we're going to do example 1. We've already read this. I know you didn't get it on the recording there, but let's just jump into how we do it. So you're going to put your independent variable, your x variable, guys, in list 1, okay? And you're going to put your dependent variables, your y variable, in list 2. So go ahead and grab your calculator. And thank you, Jocelyn. Please do that because I'll feel bad if I'm... So we're going to go to Stat. We're going to edit our list. We're going to clear out that list and put in all the golf speeds. They do not have to be in order, but whatever order you put over here, make sure that corresponding value goes with it. So I typically just do it in the order they give me. That way that my x matches my y's all the time. Again, this will be the most time-consuming part, okay? So take your time, make sure you have all of them in correctly. I call it fat fingers when my finger hits like 5 buttons at one time. All right. Once you get your data in here, we are going to go to, and if you follow it, Stat, Calc, but instead of one variable stats, it's conveniently 4 for chapter 4, linear regression, okay? And I'm going to show you something that happens. So when you hit linear regression, mine's old, so it doesn't ask me anything, but if you guys have one, you want to make sure it asks you for your X list, I think, so make sure that's list 1. Your Y list, list 2, is that it? And then you just hit calculate. You'll hit enter. And depending on whether your calculator's been used for this or not, you might have different results. And so I have A, B, R squared, R, but if you have a newer calculator or this calculator hasn't been used for linear regression, you might just have A and B, correct? Okay? So everybody should have Y equals AX, B, and A and B, but not all of us have this R squared. So what we need to do is we need to turn on our diagnostic. But guys, everyone that was here today, once you turn it on, it's on. So you don't need to remember these steps or anything like that. It'll always be on. So how we turn on our diagnostic is you want to hit second, where's the catalog? Thank you. I'm like, I know it's 0. So second 0. And this is an alphabetical catalog of everything your calculator can do. We want to get to the diagnostic. So if you see all these letters in green, the D's right above the X minus 1. So it jumps to the D's real quick, and then just scroll down until you find diagnostic. Since it's alphabetical, diagnostic off comes first, but we want diagnostic on. Okay? You hit enter and enter one more time so it says done. Once you have it done, that's the only time you have to do it. Now go back to Stat, Calc, 4, and everybody should have the same thing. Does that look right? Okay. The y equals ax plus b and the a and b values are not until 4.2. What we want, r squared, is not until 4.3. What we want is that r value, okay? That r is the core, and this is what I'm talking about. All these will be thrown at you, but the test will say, what is your correlation coefficient? So you need to know that's r. So off to the side here, we'll write r equals, it's usually the 3 or 4. I do 4. Sometimes my math lab does 3. 9, 3, 8, 7. Does that look right? And so what the heck does that mean? Well, it tells you how strong the relationship is. It says, okay, first it's a positive number, so we know as our golf club increases, our distance increases. But isn't that a positive number that's pretty close to 1? Meaning the relationship's pretty strong. How far your golf ball goes is pretty dependent on how fast you swing the club, okay? But then the question arises, well, how close to 1 is close enough, right? So what if this was like 0.8387 or 0.7387? Like, at what point are we like, okay, we're not close to 1, this is not a good relationship? That's what Objective 4 is about, okay? So this is the answer for number 1, okay? They want us to figure out the correlation coefficient. That was R. And we used our calculator. So don't do anything by hand in chapter 4, all right? So Objective 4 says, well, how do you know the correlation between two variables is strong enough to conclude that there's an actual relationship there? What they do is actually based on your sample size, okay? So it says first, figure out the absolute value. Meaning, if this was negative, we're just worried about the absolute value, 9387. We're just worried about the number part. Once you have that, you have a table in your book. On my math lab, guys, how do I pull this? on my math lab, they will have this as a link that pops up. So if they say how strong of a relationship it is, it'll be a link that you can pop up. So what we're going to do is, this is your sample size. How many golf swings did we have? It's the pairing. It's not all of them total, it's the pairing. We had 1, 2, 3, 4, 5, 6, 7, 8, okay? So our sample size, n equals 8 swings, right? So what we do is we go down to 8 and we look at this number. And this number that they give us is kind of like the bottom line, meaning as long as our value's higher than that, it has a relationship. So as long as we're above 707, we have a linear relationship. Well, what was ours? 9387. So we were easily above it. Notice the smaller amount you have, the pickier they are, right? If you're going to have 3 lines, they better look like a line. So that's why your R has to be really, really high. If you go down to 14, they're not as picky because getting 14 points to line up as a line is harder. So they're not as picky, all right? So we have n equals 8 swings, which means we go here and look at this value, okay? So since R equals 0.9387's absolute value of 0.93, I'm trying to mimic the homework, okay? So it's going to be kind of wordy. Since our R value of 9387's absolute value of 9387 is larger than the critical value of 0.707, a linear relationship exists. All right, the reason why I'm writing so much is that you guys are basically filling in a Mad Lib when it comes to homework. Have you guys done Mad Libs before? Those crazy stories where they took out like verbs and nouns and you had to fill it in. That's what they have you do here, okay? So I think you have, I'm going to try to underline the parts that you're going to have to fill in, okay? So obviously your R value is going to change, so you have to fill in the R value. So you put the actual R value. Positive, negative, you put the R value. And then the second fill in the blank is the absolute value. So if your R value is positive, the absolute value is just that number. But if your R value is negative, you just put the positive in there, okay? You have to choose whether it's larger or smaller than the critical value, which they're going to ask you what the critical value is. So a linear relationship does exist, or they'll say no linear relationship exists. Again, I'm a big hand holder. I want to help you as much as possible to match that homework. Basically, in a nutshell, guys, 9387, think of it as a test score. If you got a 94% on your test, that's really good, so you'd be happy with it. This kind of just said as long as you got a 71 on the test, you would be good. Are there any questions there? All right, let's look at this last objective. On the top of page 5, it just says, explain the difference between correlation and causation. Basically, in a nutshell, I'll read it, but correlation means they're going in the same direction. Going in the same direction. So as one goes up, the other one's going up, or as one goes up, the other one's going down. Causation is when one's causing the other. Causation is when one causes the other. So let me read it, and then we'll kind of fill in the blanks a little bit. Because it is important. Like, if you're an actual researcher doing this stuff and you find that your correlation coefficient is really high, you're like, oh, they cause each other. No, something else might be happening. So it says, if data is used in a study that are observational, we cannot always conclude that two correlated variables always have a causal relationship, meaning one causes the other. For example, the correlation between teenage birth rate and homicide, so murder rates since 1993, is 0.9987. So basically a perfect relationship. But we cannot conclude that higher teenage birth rates cause a higher homicide rate. Most likely, as it's often the case in time series data, there seems to be a correlation simply because both variables happen to be moving in the same direction. So do you guys really think that since the birth rate's high, it's causing more homicide rates? No, but what happens, guys, is there's a lurking variable. If there's more births at teenage, what's happening to our population? It's going up, right? Your population's increasing. But in general, the higher the population, what's happening to your crime? It's going up, right? So that's all this is showing you, is that one's going up, so is the other one, but because the population's going up. So we have that lurking variable, and that's your the fill in the blanks. So I'll put lurking variable here. And lurking variable here. All right, let's read the problem and see how this fills in. It says, similar data may be correlated but not have a causal relationship, meaning one causes the other, due to a lurking variable. For instance, AC bills can be used to explain crime rates. That does not make sense. My sister is actually a sergeant up in Sangamon County, and she says it's almost spot on. The second it starts getting nice outside, the calls are crazy. She's having to go see everyone because when it's bad outside, not even the criminals want to come outside, whether it's rainy or cold, right? So as the temperature gets nicer, so is the crime rate. And that's just the lurking variable, your weather, your temperature. So if the AC bills are going high, it's because it's nice outside and it's getting hot, so the criminals don't mind being outside and breaking in or doing whatever they are, okay? So that lurking variable of air temperature is what's causing both to go in the same direction. One's not causing the other.